Welcome in. All right, so instantaneous velocity. Now, velocity in general, as it ties in to speed, I can put up a link up above there to the general speed and velocity discussion. Instantaneous velocity is a little bit different because it captures the velocity at an instant in time. So a very nice kind of understanding of it is if you would be driving in a car and you're moving along, you basically look at your speedometer, which is telling you your instantaneous speed. Now, if it is showing you the direction you're going, then you can combine the speed and the direction and you can obtain your velocity. But it's at an instant in time. At that current time, how quickly are you moving? So that is a little bit different than your average velocity, which basically is between 2 points in time. So some initial time and some final time. How much total displacement did you cover? And then you divide that by your change in time. So that was your average velocity, right? So your average velocity that you could observe is your change in your total displacement, okay, divided by the actual change in time. And that we can calculate easily from a graph. And that's what I want to be able to show you, okay, for instantaneous velocity. How to capture these instantaneous velocities from graphs when you're just kicking off and starting physics and you don't have necessarily all the tools that maybe math can provide you yet, okay? So let's look at graphs. Let's find out how to calculate instantaneous velocity and then compare it to average velocity. So here is a very simple graph and it has a straight line. Now for straight lines, we can really find out that the actual average, okay, turns out to just simply be the slope of the line when you are dealing with a position and a time graph. So in this case, what we have is we have some particular distance, okay, that is being covered overall, okay, your position as you're moving along, okay, and then the time keeps ticking away. Now, in order to find the average, okay, someone has to tell you, okay, well, what do you want that average to be over? So you have to find your initial, okay, and then your final, okay, positions that you are interested in, or your initial time and your final time. So for this one, let's make it simple on us, and let's say that we want the average, okay, between our starting time, okay, and let's say 6 seconds, okay, which might be our ending time. So here we have our t final, which is just equal to 6 seconds. We have our t initial, which is equal to 0 seconds. And as you can see, so time has elapsed overall, which this basically means that our change in time was 6 seconds, because 6 minus 0. Now, between those 2 points in time, we can find out what the displacement change was by simply taking your final position minus your initial position. And in this case, you can see that we're moving east, okay? So I'm going to drop the east right here, and we've covered 40 meters, okay? So this is east, and then minus the 0 meters, which would have been your initial starting point. I guess that's your reference. And you would have had, 40 meters east, okay, as your total change in displacement. And now, in order to find out, you can certainly substitute this in, but as you can see, this is nothing else but simply the rise, okay, over the run. The rise itself is 40, okay, and then the run itself is 6. And that's exactly what the slope is telling us. So the slope, m, is simply the rise over run, which would have been 40 meters, okay, over the 6 seconds, which of course aligns with the actual formula. And this gives us the actual slope, which would be the average velocity during that time, and we can calculate it, okay, by just doing the division. So once we have that, we can figure out the actual averages. But what's the difference now, okay, with regards to instantaneous velocities? Because instantaneous velocities do not look at 2 points in time and then taking the average in between there. They're interested in, okay, at a particular time. So if someone says, okay, what was the actual velocity at 3 seconds? So they're not saying what the average was between one point and another. They're saying is how fast, okay, are you moving at 3 seconds? Well, at 3 seconds, if we would do that, then we would just simply go over to our graph, and we can certainly read out exactly what the position was at 3 seconds. But having just the position is not enough to be able to find out velocity. So it turns out that instantaneous velocity, when you're going to be reading it off from the graph, all it is actually the slope at the actual point. So this is the slope at the point, which is a tangent to the actual graph that you've plotted out. But you might say, oh, well, but the slope itself, if I try to put a tangent, right, at this particular point, I'm going to just get a straight line, which is exactly the same. That is true, but that's because in this graph, the actual velocity that you're moving at, notice that it is at a straight line. So what that is telling us, that at every single point on the line, the slope is going to be the same. So the slope, if you would draw out what that slope would be, you know, if I would try to put it on this, it's going to be exactly, okay, right on the line. Well, we have just calculated what that slope is. Okay, we found the average, but the average between those two particular any points on a straight line is always going to be the same. So in this case, the instantaneous velocity and the average velocities are identical, okay, at no matter what the duration is and at any point. So here, sure, we can find out what the slope is. Now, I'm not going to recalculate it again because I know that I have 40, okay, divided by 6, okay, so that's going to be, I'm going to just round it to 2 sig figs. This would have been our actual slope, and now notice it is east, okay? So it is the tangent, okay, to that particular point. So again, in terms of summarizing, the average velocity is the velocity between 2 points in time, while the instantaneous velocity is the velocity at a specific point in time. Those are the differences. Now, with the tools that we have, at least we do understand slope, and hopefully we do understand tangent, okay, to a particular line. So let me give you another example, okay? So this example was rather simple because we have a straight line. So for straight lines on graphs, that means that whatever object that is, it is moving at a constant velocity. It's not changing. So the instantaneous velocity will be the same as any average that you take. But as soon as you do not deal with straight lines for your position time graph, if it's some kind of a curve, then, okay, that is now different. So let's take a look at this example. So we have, okay, this, you know, huge graph here of your position and your time. Looks like we are moving, okay, now west, we have our unit, okay, and then we have our unit for our time. And notice that we have, okay, this curve. Now, I have pre-drawn, okay, a tangent at a particular point right there. I'm going to just remove, okay, that particular line, okay, just so that you don't think that it's part of the graph. So I'm going to just kind of shift it out of the way for the moment, and I'll come back to it. So let's imagine that this is now my actual position time graph. It's not a straight line, right? So in this case, if we wanted to find out any kind of an average in between here, okay, so as you would be looking along, you can take any 2 points, right? Now, let's imagine, okay, that someone asks what is, okay, the average between the points. So at time, so t initial, let's say, is equal to 1 second, okay, and then maybe let's say t final, right? So as you're kind of moving along, let's say maybe it's 3 seconds. So as soon as someone gives you 2 points in time, then you can calculate the average. Now from a graph, it's still the same. It's still going to be what the actual changes are. So now we can read this off and we can say, okay, well, this is 1 point, okay, and then 3, okay, so this looks like it's another point over here. Now we can connect these two and we can figure out exactly what the slope is there, right? So we can have those, okay, and then find out exactly what that slope might be. Now, as you can see there, that slope, that line, it's not a straight line. The red line, so this line that you see here, this is the actual position time graph. But the average is between these 2 points. Here's 1 point, here's another. So going back to find out that particular average, well, what we would have is we would have to find out, okay, what is the rise over the run, okay, in between there, because that is indeed the change in displacement. That's the rise over run, okay, and then it is what is the change, okay, in that. Well, so in this case, so if you're going through, so here we would have, here is my run, so it's moving along, so we know that it's 2 seconds because it's between 3 seconds and 1 second right there. And then here is my rise that I have, and that rise is between those 2 particular values. Now, if you were trying to map this out in here, reading it from the actual graph, sure, you know, you can find out exactly what this point is, and you can find out exactly what this point is right there. Okay, so we would have those. Let me shift this over a little bit. Okay, and now let me read it off. So we have in here, now this point, right, and this point, so that's my rise in between there. Now I'm going to take a look. This is graphed in there, and it looks like, so I have 5 over here. Notice 5, 10, 15. And then this is divided by, so this is 0, so it's divided into 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10. So this looks like it was at 1 meter over here, and this looks like it was 9 meters over there. And notice the direction or the position was going west. So it's going to be 9 minus the 1, which is 8 meters. So this is going to be 8 meters, okay, going west, divided by the 2 seconds that has passed by. And what I have found is my average between those 2 points in time. So this would have been actually 4 meters per second, okay, and it would have been west. That's an average. But if you want to find out what the instantaneous, let's say, velocity is, then that instantaneous means, okay, someone has to tell you, okay, at what point in time or at what position in time. So that is now different. Okay, so let me remove this for the moment. And let's say that now I wanted to find out exactly what my velocity, my instantaneous velocity was. Let's say at 1 second over here. Now, I think, let's see if I drew this correctly right there. So there it is. This is what we are referring to, okay, as the tangent line at a point. So it's a straight line that just touches the actual curve only at that point, and then we can span this out. Now, once we do this, and as you're initially starting off your physics, you now do have the tools of finding the slope of the line. The slope of the line, you need just the 2 points somewhere, okay, on this particular graph. So as you're going through, okay, so we would have, I'm going to span this out as far as I can, just so that I can hopefully find it on some grid. So now, okay, notice what I'm going to do here is I'm going to kind of go along this particular line, and I'm going to try to find, okay, an actual slope. So I need 2 points. Now I know, okay, that right here I do have that particular point, which is 1 second. Okay, and that's the position is 1 meter west. Now I need another one. You can take any points, but ideally you would want to take a point somewhere where it actually crosses nicely through the grid. So I'm just kind of looking through here and trying to see if it's going to cross the grid somewhere. So let's take a look here. So not here. Okay, no, nowhere over here. Looks very close over here. Okay, like it's crossing through the little grid there. Okay, so notice almost crossing through the grid. Okay, this one looks like it's almost crossing through the grid. I'm going to just kind of keep going here and let's see if I can find something maybe a little bit further. Okay, so here, okay, it looks like it's crossing through the grid. So maybe let's take that point. I'm going to change the color here so it stands out. So I'm going to just change and take this one. Now, you are approximating. It's not going to be perfect because you have an actual line. You drew that line. Or you're reading it off from the actual graph. So I'm going to take this one. Okay, so that's going to be my 1 point, and then I guess I will take, okay, the other one, or maybe, I'll take, okay, this one over here. And now I need my rise over my run. And that it would be the instantaneous velocity at position 1 meter west or at time 1 second. And for this one, okay, so let's try it. So here is my, my run. Okay, it's going to be all the way. So it looks like it goes all the way over here. Okay, and then my rise is going to go all the way over there. So that's my rise. So that's my rise. This is my run. So that's going to find out my slope. It is positive, right? So it's going to be positive. So it's still west right there. So let's see what it is. So it's, from 1 all the way up to 6. And this looks like, and let's see, what is this divided into? 1, 2, 3, 4, and 5. So we have 5. All right. So that means that those divisions, so that looks like this is 5.2 over here, 5.4, 5.6, 5.8, 6. All right, so that means this is 6.2, 6.4. So this is going to be the 6.4 seconds, okay, over here that I have. And that means that my run, so notice it's 6.4 minus the 1 second, which is 5.4 seconds. So that's my run. My rise goes from 1 all the way up to 11. Okay, so it looks like, okay, so this goes all the way down, okay, over here. So that's 11. So that's going to be 11 meters. This is 1 meter. So that means the difference is going to be 10 meters. And there you have it. So my slope for my instantaneous velocity would have been, so this is going to be 10 meters all over 6.4 seconds. And we can find out what that is. So 10 divided by 6.4. And we can round this. I'm going to round it to, let's say, 2 significant figures here. 1.6, okay, meters per second west. Okay, so it is still positive. If you would find that the slope is negative, right, so that means negative west, it just simply means that the instantaneous velocity is actually in the opposite direction, it would have been east. So just remember those. So these are actual vectors. All right, so that's how you can find this. Now, if you want to find it somewhere else, you certainly can. So, if you wanted to find what your slope is, let's say at this particular point in time, okay, so let's say it was at 3 seconds, maybe that's what you wanted to do. And now you wanted to find what's the instantaneous over here. You would need to find a tangent line, okay, that goes through that point, right? So let's say right there. And now, as you can see, the slope changes. Notice it's steeper, right? So the instantaneous, so it looks like we're going to be speeding up here because it looks like the slopes are steeper. So as you're going along, the instantaneous, right? So here is basically almost flat, okay? Here is this, okay? And you can see that it's getting steeper and steeper and steeper, which means that it's getting more and more positive. And that means that if we were trying to find what our rise over run is, okay, it's going to get more positive. So it's going to be bigger. So it looks like we're speeding up on this particular graph. And if we're speeding up, that means we have an acceleration in here of some kind. So that is how you find your instantaneous velocity. And how do you designate your instantaneous velocity? So we typically, can write it so it's still a vector. And if you want to, be really, just don't put little I, because sometimes people think it's initial. So you can put INS or INST for instantaneous, okay, to designate it. So for us, the instantaneous velocity, this was at 1 second. Notice it's at a particular point in time, was approximately 1.6, I think. That's 1.6 meters per second. Okay, and don't forget your direction, west, unless you are just interested in the speed, which you would take the magnitude. So there you have it. That's how you can find it. So anytime anyone gives you a position time graph, think of tangents at a point, span them out so that they're long enough so that you can find 2 points hopefully in a grid. If they don't fall on a grid, then just guess in between the grid, find your rise, find your run, and then you'll have what that instantaneous velocity is at that point. All right, thanks for watching. See you in a future video. Bye, everybody.